Hi students, this is the beginning of our 4.8 notes, and I just wanted to do a little sidebar background. And so just in case you forgot about some exponent rules, it might be kind of helpful to keep these in our mind. And so I've got here x to the third power times x to the fifth power. When they're being multiplied and you see two bases, we want to add the exponents. So another way of writing that is with the formula, x to the a power times x to the b power equals x to the a plus b. And then when we have just one base, like I'm seeing on this other side, but there are two exponents, the rule there is to multiply. 3 times 5 is 15. And of course the formula, a to the b power, right, is really the ab power. We multiply those. So I want to kind of use that to think about this idea shown here. So how would I fill this blank in? And what I love about math is that there are so many different ways to write the same thing. Just like in English, you write a poem about a beautiful flower. You can use so many different synonyms and descriptive words. There are different ways that we can write the same expression. So I'm trying to think, 9 to what exponent is equal to 3 to the first power? Okay, so I'm trying to think. So another way of writing 9, as we know, is that 9 is 3 times 3, or 3 to the second power. And so if I'm going to be multiplying the exponents, 2 times what makes 1? So that is actually going to be 2 times 1/2. So the shortcut is that 9 to the 1/2 power is equal to 3. Let's take another example of this. So I've got here 16 is the same as 4 squared, but I want to be able to write 16 to what exponent, and it goes all the way to 4 to the first power. So this would be called the work step, right? We start with the original and then we go to the answer. But in between, usually we do some work. And so again here, I've got 2 times something is equal to 1, and that's 2 times 1/2. So 16 to the 1/2 power is equal to 4. 16 to the 1/2 power is equal to 4. That is what you would write down as just an equivalency. So I'm wondering, okay, is there another number that this might work for? This number to the 1/2 power is equal to 5, or this number to the 1/2 power is equal to 6. Hopefully you thought of 25 and 36. And so if we are thinking about this, what we may have discovered and maybe just remembered is that any number to the 1/2 power is equal to the square root of that number. And so I selected numbers that would simplify to whole numbers to begin with, just to kind of refresh our memory. But we can use this idea here to write all kinds of exponent expressions. So let's take a look at what I'm saying here. So rational exponents, rational is the math word for fraction exponents. Hello. Fraction exponents are used to represent powers of numbers. And so we need to be mindful of where the numerator and the denominator is. So we've got the denominator n, and that's the little number that's going to go on the outside and in the pocket. We see that here and here. And that's really important because we're going to be able to translate or convert from a fraction exponent into a radical expression, and or from a radical expression to a fractional exponent. And then we want to use our rules of exponents, like I was writing 16 is equal to 4 to the second, to rewrite our base numbers in lowest exponential form. Whenever we see a number, we want to see, is there a way that I could write that with maybe powers of 2 or powers of 3 or powers of a smaller number, so that I could use some of those exponent rules maybe to simplify. So we see here in A, The square root, as you notice, it doesn't have a little n in the pocket. It's a secret 2. Or we call it the secret index because it's implied, right? The same way that on x plus 5, we don't say, well, that's x to the first power plus 5. No, it's implied that it's x to the first power. We don't even need to write it. And so same with square root. We wouldn't have that symbol if there wasn't something in the denominator. We would have written x to the first power. And of course we can simplify these to find the numerical answer, but then looking at C, if there's a number other than 2 in the denominator of the fraction, we have to write that in the pocket. And you see that the numerator will go on the radicand, which is the number inside the radical. So when I want to write 1, 2, and 3 in simplest radical form, I start by writing the radical symbol. I put the denominator in the pocket, and I see the base is x, so I write x, regular size, and the numerator is 2. So this is what I would do. For number 2, I draw the radical symbol. The denominator is 4, so 4 goes in the pocket. That's the index is 4. It's saying, what's the 4th root? What to the 4th power made this? And then I have a to the 7th power. No, sorry, we have to simplify this. I could also simplify this right here, or I could simplify it here. So notice how 7 is bigger than 4. So that means that I could have written this as a to the first power, right, times a to the 3/4 power, right? 7 over 4 is the decimal 1.75, or 1 3/4. Okay, and so that's why I was able to write it as 2 separate things. So if I erase this, that means that I could write it as a to the first power, which is just a, times, and then only this part would go in the radical. So then I would draw the radical. The 4 is in the denominator. A is the base, and then the numerator is 3. Now, how would I do that if I had just started with the radical? So this is good. If I'm starting with the radical, one way that I can do it is I know that a to the 7th means 7 a's. So it'd be like a to the 4th power times a to the 3rd power. 4 and 3 add to 7, and that's really nice. And then I would be able to say, oh, a to the 4th in the 4th root. Remember how you can kind of separate it? And then, oops, I put a 3. The 4th root here. So these cancel each other out, and I end up with a, and then I still have the 4th root of a to the 3rd. So you can use your powers, or if some students don't like that, they can also do it the long way. So this is the 3rd way you could have done it. I'm going to write 7a as 1, 2, 3, 4, 5, 6, 7, and I'm going to look for groups of 4 because that's what 4th root means. So here's one group of 4, and then there are 3 left over. So the one group comes out as a to the 1 power, and then I would still have the 4th root of a to the 3rd. I keep running to write the 3, so just be really careful with that because I keep seeing that there are 3 a's, and I'm just getting a little bit ahead of myself. So that one was a lot of fun. There are all these different ways that we can get to this answer, and you're going to pick the one that makes most sense to you. Like I'm saying, with math, there are different routes, and it's kind of what makes it so fun. So here I've got 64 to the 1/3, and I can think of 64 to 1/3. I can write it in radical form right away. See that I'm going to write the radical. The denominator is 3. It would be 64 to the 1st power. And from here, I can say 64, well, that's really 8 times 8. And 8 is 2 times 4, which we actually know 2 to the 3rd, right? And so then I would have 2 times 2 and 2 times 2. So I'm going to, again, look for groups of 3. So here's a group of 3 2's. So even with numbers, we can do that same thing that we were doing last time. And then here's another group of 3 2s. So that's going to come out as 2 times 2, which is 4. And 4 is the final answer to this. Another way I could have written this is that, well, actually 4 to the 3rd power is equal to 64. And when I multiply those exponents, I do get just 4. One more way, 2 to the 6th power is equal to 64. When I multiply those, I get 2 to the 2nd power, which, as you know, is equal to 4. So all these different pathways to get to the same answer, pick the way that makes the most sense to you. So if you're like, you know what, I really love just using the radicals, I understand that, do that. If you say, no, I'm easily able to translate a number that's large into its base powers or its prime factorization, and I just want to use exponent rules, you can do that too, since they all yield the same answer. All right, let's take a look. Okay, so with 1/2 power, hey, I just know that that's the square root of x. Easy peasy. For number 5, oh, I have a negative exponent. So in case you forgot, negative exponent means in the denominator. So I'm going to write 1 over to begin, and then I think of the expression with a positive exponent will just be in the denominator. So I'm going to say square root of 49, which the square root of 49 is 7. So the final answer to this one is 1 over 7. And I'm just going to leave it in that radical form. Or, of course, we could have said 1 over 7 squared to the 1/2 power, multiply the exponents, and we get 1 over 7 that way too. These are so fun. Sorry, I just love them. And then number 6, this is a cool one. So I have a negative exponent on a fraction. So really I've got 1 over 1/8, which is better to be written as 1 divided by 1/8. And remember, when we do that, have that division, we just refresh our memory with this, we multiply by the reciprocal. So it'd be 1 times 8 over 1, which is just 8. So is there a shortcut to doing that? Yes. What I could have done is seen I have a fraction. When I have a negative exponent, that just means that I flip the fraction upside down, and that's going to be our answer. So I'm going to change this to 8 over 1 to the positive 1/3. So I reciprocal the fraction, and then I have already dealt with the negative exponent, which is usually the trickier part. 8 over 1 is just the number 8, so I don't really need that 1 there. So I'm really thinking, okay, 8 to the 1/3 power. So it's the 3rd root of 8, and 8, you know, is 2 to the 3rd power. So 2 to the 3rd, inside of the 3rd root, those exponents cancel each other out, and the final answer for this is the number 2. Very cool. Let's get a little bit more practice. So we're just rewriting expressions using their fraction exponents. So in this case, I want to go from radical form to the exponent form. So in this case, what I'm always going to do is write down the base first. So I see the base is the letter z, and then I write my fraction exponent. I write the denominator is 3. The numerator would be the exponent on z, 2. So we always need to write the denominator first so that we remember to have a fraction. Sometimes students will just totally forget that it's a fraction exponent. They just write down the number that they see. So they might say that if this had been z in the 3rd root, they might accidentally write it as z to the 3rd power. All right, number 8. So here's 32, which is not 32. That's 8 times 4, which is 2 to the 3rd times 2 to the 2nd, which really makes 2 to the 5th power. So I really want to write this in exponential form. So I want to write it with the lowest, with exponents, right? So I'm going to say this is 2 to the 5th inside of the 6th root. So now I'm going to write this with the base of 2, the exponent, the denominator is 6, and the numerator is 5. 2 to the 5 over 6 power. This is the simplest way to write this. If you don't rewrite the 32 and you leave it as 32 to the 1/6, that's not simplest exponential form. It's not technically in exponential form because 32 could be written with exponents. All right, number 9. So I'm going to start like normal. I'm going to say, okay, the base is C. The denominator is 4. The numerator is -5. Okay. Or, I don't love leaving a negative exponent in the answer. So I would say 1 over C to the 5 over 4 so that I have a positive exponent. I think that this is going to be my best answer. So here I have some problems where I'm going to be evaluating. Yes, all right. So 25, let's rewrite that as 5 squared. Or I'm going to use the exponent form. If you prefer to use radical form to simplify this, you can. So I'm going to write it as 5 squared to the 3/2. How will I write 11 with exponents? So 27, I would write that as 3 to the 3rd power to the 2/3. Let's just do this conversion first. -64. So I can't write that with an even power or it wouldn't be negative. So I'm actually going to write that as -4 to the 3rd power to the 2/3 instead of writing it as 2 to the 6th power because 2 to the 6th power would be an even number. And then 64. Okay, so that one I'm going to write with 2 to the 6th. 25 I'm going to write as 5 to the 2nd. And all of this to the -1/2. I'm just writing them with their base powers as practice. So you can easily translate to the base power and do it this way too. So now I multiply the exponents. So I always change it to a fraction. It's going to be 5 to the 6 over 2, which is 5 to the 3rd. And I'm going to write that as a number, a one value, which is 125. Cool, that was cool. Okay, number 11, I changed that 3 to 3 over 1 as the exponent, multiplying across. I get 3 to the 6 over 3, which again is going to be 3 squared. And so the numerical answer here, 3 squared, is 9. Loving these. These are fun. Okay. Number 13, change it to 3 over 1. It's going to be -4 to the 6 over 3, -4 to the 2nd power. So keep in mind it's negative times a negative. So that's going to be positive 16. These are fun. Okay. What about this? This one is kind of tricky. Remember, we've got that negative exponent. So we want to start by getting rid of the negative by changing this to the reciprocal. So 5 squared over 2 to the 6th power. Now just the 1/2. And so I do distribute this half power to both the numerator and the denominator, making this 5 to the 1st power over 2 to the 1/2 of 6, 3rd power, which simplifies the number 5 over 8. And that is evaluating using rational exponents. So it looks like we have an error and we have some duplicates on 15 to 17. So now let's take a look at instead saying oops. And we'll just look at 18, 19, and 20, and then we'll be done. So I see that I've got a lot going on here, and I'm feeling a little bit overwhelmed. So on 18, I see that I have the 1/2 power on the outside, and I am going to write this whole thing in a square root. I think that that's going to be the easiest way. So I've got x to the 3rd power, y to the 7th power, z to the 8th power. And then I'm going to do the grouping rule. So x to the 3rd, that's 3 x's. Take out 2 of them because I'm looking for pairs of 2. So it's going to be x on the outside, and then I like to do this 1x on the inside. So I write the numbers on the outside, like I leave a lot of space. So then with y to the 7th, I'm going to write 1, 2, 3, 4, 5, 6, 7. So I'm looking for pairs of 2, 1 pair, 2 pair, 3 pairs of 2. So that's going to come out as y to the 3rd power. And then there's 1 y left over. And then with z to the 8th power, so that would be z, 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 1, 2, 3, 4. So that would come out evenly as z to the 4th power. So to write this so that it looks its best, x, y cubed, z to the 4th, oh, whoops, and then rad xy as our simplest radical form. In exponential form, okay, in exponential form, I'm going to erase this. In exponential form, I write it as, x, so 3 with the denominator of 2. Y, 7 with the denominator of 2. And then z, 8 with the denominator of 2 simplifies to 4. Cool. So these are not so bad. Just go slowly and make sure to show your work. So according to number 19, I see that I have a number that has an exponent and then it's being multiplied. So PEMDAS says deal with the exponents first. So that's what I'm going to do. I'm going to write this as, giving myself some space back, 8 to the 1/3, that's going to be 2 to the 3rd to the 1/3, and then 5, nope, I did it again. See, I like to write the base. I'm going to say x to the 5 denominator 3. So doing the work here, I'm going to have 3 and 3 cancel out, and I'm going to have 2 x to the 5/3 times, and now I'm going to do this again, 2 x to the 5/3. Very interesting. So what do I do here? I'm going to multiply the matching parts, and because it's multiplication, add the exponents. So 2 times 2, that's just the number 4. But then I have x to the 5/3 times x to the 5/3. So what I do is x to the 5/3 plus x 5/3. So when I add those, I get x to the 10/3, and here is the 4. This is exponential form. Well, in simplest root form, the 4 doesn't have a fraction exponent, so I don't need to worry about that. But I would write it as the 3rd root of x to the 10th power, and then I could do that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 group of 3, 2 groups of 3, 3 groups of 3, 1 left over. So that means that it would simplify as 4 x to the 3rd power, and then the 3rd root of x to the 1st power. So these are the 2 answers. All right, number 20. So inside here, I have that negative 125. I'm going to write that as negative 5 to the 3rd. And then I've got x to the 4th, And I've got the square root of x, which I'm going to rewrite back as an exponent, so I can do this exponent stuff. It's x to the 1/2. And really, I'm going to just change these with addition to x. 4 plus 1/2 is 4 1/2. But 4 1/2, if I was going to write that, it would be 5 halves. No, it wouldn't. 4 plus 1/2 is 4 1/2. Then I do 4 times 2 plus 1. So 8 plus 1 is 9 halves. All right, so it's 9 halves. -5 to the 3rd. Okay, so that's just what's inside here. Wow, even I got a little jumbled with that. Then I've got the 2/3. So I'm going to distribute with multiplication that exponent. This is going to be -5 to the 3rd times 2/3, changing that to 3/1. It's going to give me -5 to the 6/3, which is -5 squared. So I show all my work. Then I have x to the 9 halves times 2/3, which gives me x to the 18/6, which is x to the 3rd, which is almost the answer. But I want to simplify that -5 squared. So -5 times -5, positive 25 x to the 3rd. And that is simplest radical form because there are no fractional exponents. So that is going to do it for today. I cannot wait to answer your questions and go over some more practice problems with you.